Shown below is the data for a study conducted on a vitamin supplement that claims to shorten the length of the common cold. So we've got number of months and then the number of days the cold lasted. And it looks like we've got a least squared regression line for this data. So that's like a line of best fit. And it's right here. So the first question says, use the least squared regression line to predict how long a cold will last for a person who has taken the supplement for 3 months. So I'm going to, so months is X and the number of days the cold lasted is Y. So I'm going to plug in 3 for X here. So Y equals negative 1.58 times 3 months plus 5.37. And I'm going to use a calculator to answer this. So negative 1.58 times 3 is negative 4.74 plus 5.37 is 0.63. So that says that, so a cold will last, so if a person has been taking the supplement and they get a cold, then the cold should last number of days. It should last 0.63 days. If they've been taking the supplement for 3 months. And you can see that right here, because if we go to 3 months, which is halfway between 2 and 4, and we go up here, and then we go over, this would be 1, that line would right there would be 0.5, so this is about 0.63, so that makes sense. How long do you predict the cold would last for a person who has taken no supplement? So that means that's the Y-intercept. Like a person who has not taken the supplement at all, they've taken the supplement for 0 months, we would expect the cold to last right here, this many days. So that would be what our Y-intercept is, 5.37. What does the slope represent in this context? What does it tell you about the effectiveness of the supplement? So the slope is the change in Y over the change in X, which would be the number of days the cold lasts over number of months taking the supplement. So that means that for this slope right here, 1.58, it means that for every 1 month taking the supplement, a cold will last 1.58 days shorter or fewer So for every month you take the supplement, your colds are going to last less and less long. If you had a cold, would you want your data point to have a negative or a positive residual? Explain why. So let's see, if I had a cold and I was taking the supplement, I would want my cold to last fewer days. So I would want my cold to be, so the line of best fit right here tells you like the average amount of time that a cold lasts if you're taking the supplement for a given amount of time. Let's say I had taken the supplement for 2 months. I would want my cold to last as few days as possible. So I would want my cold to be underneath the line. So I want my cold to have a negative residual. So we want it to have a negative residual because it means that your cold lasted fewer days than the prediction. Because you would want your actual to be smaller than the prediction, because you wouldn't want to have a cold for very long. Answer the following questions about this quadratic function. Put the equation in factored form by factoring with a box and a diamond. So remember, with a box and a diamond, we've got x squared right here, negative 15. The top of the diamond is the product of this diagonal, so negative 15x squared. The bottom is the sum, 2x. So I need two numbers that multiply to make negative 15 and add to make 2. That's going to be 5x and negative 3x. So then I fill out the outsides of my box. X times x gives me x squared. 5 times x is 5x. Negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. So then I can rewrite the equation by saying y equals, now I'm going to write the product of my rectangle, which is x plus 5 times x minus 3. Now find the x-intercepts by plugging in 0 for y. So 0 equals x plus 5 times x minus 3. Now I can use the zero product property. Then I subtract 5 from both sides. I get x equals negative 5. Then I add 3 to both sides. X equals 3. So my x-intercepts are negative 5, 0 and 3, 0. Find the vertex of the parabola by plugging in the x-coordinate from the line of symmetry. So first let me graph these. So my x-intercepts are negative 5, 1, 2, 3, 4, 5, 1, 2, 3. So the line of symmetry, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8 spaces in between them. So 4 spaces would be halfway. 1, 2, 3, 4. So the line of symmetry is x equals negative 1. So I plug that in to find the vertex. So y equals negative 1 squared plus 2 times negative 1 minus 15. I can plug it into this equation or that equation. It doesn't matter, they're equivalent. Y equals 1 minus 2 times negative 1 is 2 minus 15. So y equals 1, or 1 minus 2 is negative 1. Negative 1 minus 15 is negative 16. So the y-intercept is 0, negative 16. Or sorry, the vertex is negative 1, negative 16. So maybe I'll go by 2, 4, 6, 2, 4, 6, 8, negative 10, 12, 14, 16. So here's the vertex. Put the equation in vertex form by completing the square. So the equation was y equals x squared plus 2x minus 15. So to complete the square, I've got an x squared right here. I've got 2 x's, one here and one there. In order to have a complete square, I only need 1 1. But I have negative 15 ones. So in order to get to 1 from negative 15, I have to add 16. So I'm going to get y plus 16 equals x squared plus 2x. So I add 16 to both sides. X squared plus 2x plus 1. So that's my square. X squared plus 2x plus 1 is this. And it's x plus 1 and x plus 1. Now I can rewrite this as the product of the length times the width. So y plus 16 equals x plus 1 squared. Then I just subtract 16 from both sides, and I get y equals x plus 1 squared minus 16. Does it match the vertex you found in part D? Well, we found that the vertex was -1, -16, -1, -16, so yes, it matches. What is the y-intercept of this parabola? So to find the y-intercept, you plug in 0 for x, because we're on the y-axis, x equals 0. So we get y equals 0 squared plus 2 times 0 minus 15, which is 0 plus 0 minus 15, which is just y equals -15. You could also look at the standard form. In standard form, the number at the end is your x-intercept. Your y-intercept, excuse me. So the y-intercept is 0, -15. Should be right here. We've got a symmetry point right there. And here's our parabola.